Welcome to the Indian Pharmacist. Today, we are focusing on the precise engineering required to maintain high-stakes pharmaceutical water systems. A modern pharmaceutical run can represent $1 million in product. If a single microscopic ion bypasses your 1200 PSI system, the batch is compromised. To cut down on massive energy costs, the industry is rapidly phasing out traditional thermal distillation. We are replacing those old boilers with high-efficiency Cold WFI, water for injection, membrane systems. By the end of this tutorial, you will know the exact daily maintenance steps required to prevent system failure, maximize your energy efficiency, and maintain strict FDA compliance. Step 1. Gather your daily digital logs and log directly into your RO Skids human-machine interface, or HMI. Mastering this routine ensures you are protecting the facility's most critical and expensive baseline asset. Start at the primary control panel and locate your upstream pretreatment gauges. Visually inspect the readouts for both your water softening and carbon filtration units to ensure they are operating within spec. RO membranes are highly sensitive. If these upstream softening or filtration processes fail, hard minerals and organic material will scale or foul your expensive membranes within days. This comparative bar chart shows the energy draw of older thermal distillation on the left versus our modern membrane system on the right. We tolerate the sensitivity of membranes because the energy savings are massive. Operating at ambient temperatures allows cold WFI systems to drastically reduce a facility's carbon footprint, making it the global standard for pharmaceutical sustainability. Consistent, strict pre-treatment monitoring guarantees you actually capture those energy benefits without prematurely destroying your equipment. Next, direct your attention to the main high-pressure pump. Verify that your readouts are consistently hitting the required 1200 PSI mark. Natural osmosis pulls clean water into dirty water to find equilibrium. We apply 1,200 pounds of pressure to force water backwards against that natural gradient through a semi-permeable barrier. This spiral-wound membrane cross-section acts as a molecular sieve. Its tight layers physically block 99.9% of bacteria, viruses, and salts. This separates the feed. Pure permeate flows down the center, while concentrated reject brine is flushed away. Your 2026 upgrade features graphene-enhanced membranes. Integrating graphene makes these elements significantly thinner and physically stronger. They also possess a high resistance to the organic fouling that ruined legacy systems. When you verify that 1200 PSI reading on your daily walkthrough, you are actively validating the structural integrity of that graphene lattice under maximum load. Step away from the main pump and locate the flow rate monitors for your continuous Electro-Deionization unit, the CEDI, and the low salt rejection elements. Reverse osmosis effectively removes solids, but it cannot catch dissolved gases like carbon dioxide. Those gases slip right through the membrane. We route the RO permeate directly into the CED unit, which uses an electrical current and specialized resin to strip out those remaining gases and achieve the required 18.2 megaohm-centimeter purity standard. At the same time, the low salt rejection, or LSRRO elements, process the reject water. They recover usable water from the brine, pushing concentrations up to 220 grams per liter. Capturing and recycling that highly concentrated brine is exactly how modern pharmaceutical plants are hitting their zero liquid discharge environmental targets. Achieving pharmaceutical-grade water requires verifying this exact continuous handoff between the RO membranes and the CED system. Once the physical flow rates are confirmed, step over to the digital dashboard to initiate your automated daily sensor calibration check. On the HMI, navigate to the sensor diagnostic stage and verify the accuracy of your total organic carbon, or TOC, sensors. The US FDA auditors will review the integrity of your digital logs with the exact same scrutiny they apply to the water itself. This dashboard line graph monitors our total organic carbon in real time. By adhering to Alcoa Plus principles for data integrity, the system detects microcontaminations and alerts operators before a batch is ruined. Immediate digital diagnostics completely replace the need to wait hours or days for reactive wet chemistry test results from the lab. Your physical gauges can read perfectly, but if the digital logs are corrupt or incomplete, you have no legal proof of compliance during an audit. Verify the automated calibration is complete and ensure your daily checks are signed and securely logged. Your pre-treatment lines are secure. The high-pressure pump is hitting its marks, the CDI handoff is balanced, and your data logs are fully compliant. Maintaining this discipline daily protects the graphene membranes from early degradation and keeps the facility's cold WFI output highly sustainable. With RO hitting these purity levels, will membrane technology completely replace the traditional multi-column still? Drop the word purity in the comments below to let us know. Subscribe for more deep dives into the critical engineering that keeps the world healthy. We will see you in the clean room.